Wait, okay, just a second now.
All right, April the 9th, 2015, Bio 100, Human Biology. Today we will discuss chapter, what?
15.
15, digestion, digestive system and nutrition. All right. When we talk about the digestive system itself, we're talking about the so-called alimentary canal. And this is a sort of a tube within a tube. Starts at the mouth and it ends at the anus, and then the average adult, roughly 28 feet long, again extending from the mouth down to the anus, approximately 8 meters. When we talk about the walls or the layers of the alimentary canal, we have 4 distinct layers. First layer being the mucosa, and that being the outermost layer, okay? And our textbook goes through this beginning on page 546. Some of the important points about the mucosa, they have
456.
I'm sorry, 456, yeah. Okay, we can see in certain areas of this mucosa, the walls of the alimentary canal are folded or take on sort of an appearance, something like that, particularly in the absorptive areas, like the duodenum. And what this does is this increases the surface area for absorption. Now, contrary to a lot of popular belief, there's most of the digestion and absorption that takes place in this alimentary canal occurs in the first division of the small intestine, the duodenum. And you'll see that the walls of the duodenum are arranged in this sort of folded arrangement, and again, it's much greater surface area than just a flat arrangement, and that provides an increased surface area for absorption of the nutrients and things that we need to stay alive. All right, now I'll just briefly touch on each one of these. The mucosa, and if you look on here, the primary function is to carry out digestion or secretion and absorption. By secretion, I mean secretion of substances like mucus, and you see OUS, US, I'm sorry. All right, and digestive enzymes. Okay. Carry out secretion and absorption. All right, so for instance, our last meal, we've eaten it. It's gone through our stomachs and undergone some changes there. But most of the digestion of nutrient, protein, fat, and carbohydrate will take place, again, most of it will take place in the first division of the small intestine, which we'll get to in a little bit. And then those nutrients, those things that we need, are absorbed, and again in the first division of the small intestine. And we'll go through some of these, we'll go through the important digestive enzymes that are secreted by the mucosa of the alimentary canal that help to break down, again, fat, protein, and carbohydrate. All right, the submucosa. Its primary function, and if you read primary function of the submucosa, nourish surrounding tissues. And to carry away absorbed nutrient, okay? You know, for instance, when we eat starch, we eat carbohydrates, the enzymes, well, carbohydrate digestion, the mechanical part of it begins in our mouth, but it is completed in the small intestine, and those carbohydrates are broken down into their constituent monosaccharides, that being glucose, fructose, and galactose, and then those substances are absorbed and carried away in the bloodstream. All right, now the muscular layer, this smooth muscle, and this provides for the movement of material through the canal, starting from when we chew and swallow till we remove the undigested material by defecation, okay? So it provides for movement of materials. And we'll see there are two types of movement that are experienced. One is called segmentation, and what this is alternating contractions of this smooth muscle to mix the food material that we eat with the digestive juices that we produce. Okay, so they contract here, contract here. It doesn't really propel the food along the canal, but it contracts back and forth to ensure that the materials that we've eaten are exposed to the enzymes that are contained in the digestive juice, okay? So that's segmentation, and then we have a second part called peristalsis. All right, and this moves material through the canal. This is carried out again by the muscular layer of the one of the layers of the alimentary canal. All right, when you are being examined by a nurse, physician, healthcare professional, and they take a stethoscope and they put it to your abdomen, primarily what they're listening for is peristaltic action. Is this taking place? One of the problems with anesthesia is that peristalsis slows down and stops. All right, and it takes a while for those anesthetic drugs to leave your system and for peristalsis to resume. And so, for instance, when you have like a so-called same-day surgery, they won't let you go home. One of the criteria is that you pass gas, which tells them that peristalsis has returned, and so they're not going to worry about it when you go home. You have something to eat, and you won't get constipated. All right, and so they listen for that. And you know, when we eat, we swallow air, and not only does the food material that we ate pass through our canal, but also air does, and it makes a sound, and so that's what they listen for. And you could, oftentimes it's audible just when you're sitting there, you know, you hear this rumbling, if you will, of your intestines, and people say, must be hungry. Well, it doesn't necessarily indicate hunger, but what it's telling you is that peristaltic action is going on, and air and what have you are moving through the alimentary canal. All right, and then the outermost layer is the serosa, and this is analogous to what they call the visceral peritoneum. All right, and this is the layer that actually adheres to and covers the surface of the organs that are in our abdominal pelvic cavity, okay? All right, so we have, excuse me, 4 primary layers. We talked about the 2 different types of movement. Just look at those. The difference between segmentation and peristalsis. And again, this is on the same page, page 457. And the primary function of this segmentation, again, is to mix foodstuffs, whatever we've eaten, with the constituents of digestive juice, primarily enzyme, okay, to help break down the food into their subunits so that these things can be absorbed and brought into the bloodstream and taken around the body. All right, so we begin this journey through the alimentary canal with the mouth. All right, and 2 types of digestion, and we'll identify 2 different types of digestion. In the mouth, 2 types take place. One is mechanical, and this is the actual physical ripping and tearing and grinding of food material that we put into our mouth. The actual physiologic term for chewing is called mastication, and I always get a chuckle from the kids when I tell them this. I said, "Did you masticate today?" And they go, "Oh, come on, man," But this is chewing. All right, this is where we rip and tear and grind the food that we eat, again, to break it down, increase the surface area of the materials so that digestive enzymes can act upon them. And then in the mouth, we also have chemical digestion that takes place. And again, this involves enzymes. There is an enzyme in the saliva, it's called salivary amylase. All right, and this begins carbohydrate digestion only. Okay, and if we look at the word amylase, amylo, the root word means starch. All right, so when we take in food and we're chewing it up and we have this enzyme, salivary amylase, that starts to work on carbohydrates and break them down into, break down these polysaccharides, starches, into disaccharides. Di means two. And there are 3 primary disaccharides, and they would be maltose, lactose, and sucrose. Okay, and what you'll notice, if you take a look at that, you'll see that those words end with the suffix OSE, os, and in physiologic terms, when we talk about words that end in os, pretty much we're talking about a sugar. We know lactose is milk sugar, maltose is malt sugar, and sucrose is common table sugar. And again, these are disaccharides. So this amylase starts to break down all the carbohydrate that's contained in the meal that we've eaten, break down these starches, into the disaccharides. Now these will be further digested in the small intestine. The complete digestion of the carbohydrates will take place in the small intestine. Take home message. In the mouth, we have two types of digestion, mechanical and chemical. And so if you're ever asked, which you may be, where does carbohydrate digestion begin? And it begins in the mouth. I tell the students in the prison, if you want to test this, when you go for some dinner and you get bread, take a little piece of bread, roll it up in a ball, and then stick it up in between your gum and your cheek and let it sit there. 5, maybe 10 minutes. After a while, you'll notice you'll start to get a little bit of a sweet taste in your mouth because the amylase is starting to break down that polysaccharide in the bread, break down the starch into disaccharides, including sucrose, and sucrose is sweet. And so you'll taste that. Okay. So the primary function of the mouth is mechanical and chemical digestion. In the mouth we have the tongue. The tongue is attached at its base to the only bone in your body that is not jointed, called the hyoid bone. And what the tongue does is to help move that food around as we're chewing and mixing it with saliva and mixing it with mucus to help form those foodstuffs into a ball called a bolus. Which then it will push to the back of the oral cavity into the oropharynx and begin the process of glutition or swallowing. And I bring up those terms because we may see them. Glutition. All right, now, I'm not going to go through them, but remember that in the mouth you have teeth. And so one thing you're going to want to be able to do is differentiate between primary teeth and secondary. Okay, our primary teeth, we have, if memory serves, we have 28 of those. Let's see. In the mouth. Primary teeth, blah, blah, blah. There are 20 primary teeth called deciduous. All right, and then we shed those, and then with the secondary teeth, the permanent teeth erupt, and we have 32 of those. Now, what you'll need to just take a look at is, the names of those teeth and the basic structure of there, and recall or remember that the teeth are covered by in fact, the hardest substance in the body that we know about is enamel. But do take a look at, in the diagram on page 461 shows you'll see it breaks down.
416. No?
Oh, 417.
417, okay, got it, yes.
I wonder why there's two different numbers on there, but anyway. So you see we have the enamel and the dentin, which make up the crown, and then the root is made up of the pulp, the gingiva, which is your gum, the alveolar process, which is the bony part of your mandible and maxilla, the root canal, the periodontal ligament, and the cementum. So just look at that. I guess remember the number of primary and permanent teeth. And remember that enamel is the hardest substance in the body, and it is not replaceable. When the enamel is lost, it does not come back. All right, and that table 15.1 on page 417 will break down the teeth for you into the type. You have incisors, canines, the so-called eye teeth, premolars, molars, and so forth.
And 15.8, you said 15.1.
I'm sorry.
15.8? Oh, table. I'm
Yeah,
sorry.
the table. I'm sorry. Yeah, 15.1.
Sorry.
That's all right. That's all right. And just note, most of it, the incisors is to bite off pieces of food, to rip. Canines, grasp and tear. And then the premolars and the molars are to grind the food. All right. We took a look at, and I mentioned the secretions from the salivary gland. Just note the 3 pairs of salivary glands that you have. You have the parotid, the submandibular, and the sublingual. Okay, and I bring that up because your parotid glands, the ones that are sort of here, just up underneath your ear, those are the ones that often become swollen when you get the mumps, when you're infected with that virus. All right. And again, the primary function of these salivary glands is to produce and secrete salivary amylase, which begins carbohydrate digestion. All right, good. All right, we'll move through. Now, moving along, just following the canal in its order. We've gone from the mouth, mentioned the teeth and the tongue, and now we'll go into the pharynx. And it is divided into 3 regions. I guess if I keep that X there, it'll stay focused, right?
Yeah.
Yeah, okay.
Or you can just leave something on the board, like sometimes you do.
All right, that's fine. We'll just do that. All right, the pharynx. Blah, blah, blah. Divided into the nasopharynx. All right, and there is a structure between the oropharynx, let's put this oropharynx, and the structure in between the oropharynx and the nasopharynx called the uvula. And you can see it when you open your mouth, look in the mirror, and you see that little flap of tissue dangling in the back of your throat. It's called the uvula, and people say, what the heck does that do? Why is it there? Well, it does have a function, and that when you swallow, that which is in your oropharynx heading toward the laryngopharynx, when you push the food back with your tongue, that uvula, that flap, moves up and covers up the nasopharynx so that what you're swallowing does not end up in the nasal cavity. Although if you've ever had fairly violent regurgitation, throwing up, you know that sometimes things come out your nose, and that's what happens. They just, because of the force, the contractions in the abdomen, force that material up the esophagus into the mouth, and then just goes right past the uvula into the nasopharynx. And it's particularly uncomfortable if you have these big chunks that are coming out. But anyway, that's what the uvula does. It closes off the nasopharynx during swallowing. And again, these are just passageways, at least for now, the nasopharynx and the oropharynx, for both air and food. And then we have the laryngopharynx. And again, this is just and this is the primary passageway into the esophagus. Okay. And again, the esophagus is that muscular tube that connects the laryngopharynx down to the stomach. Okay. Now it is, like the wall. We mentioned the four different layers of the wall of the alimentary canal, and it is lined with a muscular layer. And so when we swallow, the bolus enters into the esophagus, stretches it. The smooth muscle will contract, propel the bolus down toward the stomach, and then stretches that part. You get another contraction and so forth until the material enters into the stomach. This is why, again, we mentioned this last week, you can stand on your head and eat and drink, and the material will still make its way into your stomach against the force of gravity, although gravity does help a little bit. All right. The swallowing mechanism, I'm not too, I don't want to get too picky about that, but just recall that, once the tongue, after we've chewed and ground up this food stuff that we've taken in, the tongue will move it around, roll it into a bolus, move it into the back, into the oropharynx, and then into the laryngopharynx, and then we begin the swallowing reflex. And it is a reflexive action. And for the brief moment, when we swallow, we don't breathe. Okay, because when you swallow and the tongue pushes that food bolus into the past the oropharynx, into the laryngopharynx, it pushes on a flap of elastic cartilage called the epiglottis. And what this does is prevents the material, whatever it is we're swallowing, from entering into the airway, into the trachea.
Yeah, that was one of the test questions last exam.
Yeah.
Quiz.
So this helps prevent material from entering the trachea. Although it has happened to all of us at some time where what we swallow so-called goes down the wrong tube, and then we cough and sputter and spit, because when it goes down into the trachea, whether it be solid or liquid, when it comes in contact with the vocal cords, they will reflexively slam shut. When you do that, you're not moving any air. So what do? Well, we forcibly contract our diaphragm and our intercostals to try to force air out of our lungs to remove whatever it is that's sitting on the vocal cords. Okay. From the esophagus, we enter into the stomach, and there's a couple of important structures there because people oftentimes have trouble with that. And if you look at figure 15.11, you'll see the structures of the stomach, but the area where the esophagus penetrates through the diaphragm is called the esophageal hiatus. Okay, so this is where the esophagus comes down, goes through the diaphragm, the dome-shaped muscle, and connects with the stomach. I bring that up because a common problem, a common digestive problem that many people have is a condition called a hiatal hernia. And this is where part of the stomach, part of the fundus of the stomach sort of pokes through this hiatus through the diaphragm and into the thoracic cavity, and it hurts. And a lot of times, especially after eating, spicy meals, part of that stomach, the fundus, it already is protruding through that hiatal opening. And
Is there a surgical cure to hiatal hernia?
yeah, there's a few. Back in the old days, I remember they used to put a thing called an angel chick, a ring. And what they would do, if you look at the diagram here, they would put a constricting ring around the esophagus, right there where you see the lower esophageal sphincter, and to help prevent that part of the fundus from moving up in there. Met with varying degrees of success. I'm not sure what the mainstay treatment is right now, but I know after having done a rotation in the GI clinic, most people, or most of the people that we had done endoscopies on, exhibited some degree of herniation of their fundus through the hiatus. You know, they did me and they said I had like a grade 2 or something like that, because I used to get some really bad heartburn. This was when I was heavier, and I noticed that the problem subsided when I lost weight, and my belly wasn't as big as it was. But I'm not sure nowadays, because that was like 25 years ago, what they're doing to treat hiatal hernias. But if they get severe enough, surgery is indicated. Okay? All right. Look at the parts of the stomach. You see the upper part called the fundus. The main part is the body. You have a greater curvature and a lesser curvature. An important part that we need to keep in mind is the lower end of the stomach called the pylorus. And the pyloric sphincter, which controls the entry of material from the stomach into the first division of the small intestine, the duodenum. And under normal circumstances, the amount of material that is moved through the pyloric sphincter with each contraction, somewhere in the neighborhood of 30-40 milliliters of what is called chyme, C-H-Y-M-E, which is the name they give to what your meal looks like after it's been sitting in the stomach and has been subjected to water and the hydrochloric acid and the enzymes that are in your stomach. Now, important take home about the stomach is primarily concerned with, it begins protein digestion. Okay, not sugar and not fat, but protein. There is and some of the primary secretions from the stomach include hydrochloric acid, HCl, very powerful acid, by the way, which, kind of explains, when we eat, of course, nothing that we eat is sterile. It's got bacteria on it, regardless of whether we've cooked it or not. By the time we put it on the fork and picked it up and manipulated it and put it in our mouth, which is filled with bacteria, and swallowed it, and it makes its way into the stomach, many of these potentially bad bacteria are killed by the acid environment that's in the stomach. The pH of the stomach is somewhere around